Let's discuss question 9.43. A centrifuge in a medical laboratory rotates at an angular speed of 3600 revolution per minute. When switched off, it rotates 60 times before coming to rest. Find the constant angular acceleration of the centrifuge. So question here has given me the angular speed of 3600 revolution per minute. Now revolution per minute is the unit of frequency. So even though it says angular speed here, what we have been given is not the value of omega, which is angular speed, but the frequency. Because revolution per minute and revolution per seconds are unit of frequency. So I can write my frequency f to be 3600 revolution per minute. I can convert this revolution per minute to revolution per second by dividing this number by 60. And when you do that, you get your frequency as 60 revolution per second. We can find the angular velocity using the frequency. We know that omega, which is the angular velocity, is equal to 2 pi f. So we can multiply our frequency value with 2 pi to calculate angular velocity omega. 2 pi times 60 will give me 120 pi radian per second. So one way to identify if the question has given you angular speed or frequency is by looking at the unit. If the unit is radian per second, then it is omega, which is the angular speed. And if the unit is revolution per minute or revolution per second, then it is frequency. Then the question say when you switch off the centrifuge, it rotates 60 times before coming to rest. When it comes to rest, my omega value here will be 0. So therefore I can write omega final to be equal to 0 as the particle comes to rest at that point. This will be my omega initial. But before coming to rest, it rotates 60 times. So let n be the number of times the centrifuge rotates before coming to rest, which is 60. Now when an object is in circular motion and it goes around the circle one time, when it makes one revolution around the circle, the angle it covers in that revolution is 2 pi radian. So if this centrifuge were to rotate 60 times, the angle delta theta that it will cover in that rotation will be n times 2 pi. Because if one revolution is 2 pi radian, if you go around the same circle 60 times, your delta theta now will be 60 times 2 pi, which will be 120 pi radian. I need to find what is the value of angular acceleration alpha. So since we have angular displacement, initial velocity, and final velocity, we are going to use the fifth equation of motion to solve this problem. The fifth equation of motion says that V final squared equals V initial squared plus 2a delta x. When we rewrite this equation in angular counterparts, V get replaced by omega, acceleration gets replaced by alpha, and delta x will be replaced by delta theta. So I'm going to rewrite this expression for circular motion, and we get omega final squared equals omega initial squared plus 2 alpha delta theta. I wrote the same equation, but I replaced the linear values with angular values. I need to find what is alpha, so we can rearrange the term. The first thing we need to do is get rid of all terms which is not attached to alpha. So we have omega I squared here. I will move this to the other side. So we get omega final squared minus omega initial squared equals 2 alpha delta theta. Then we get rid of the terms which are multiplied to alpha. Since they are multiplied with alpha, I will divide with them. So alpha will be equal to omega final square minus omega initial square over 2 delta theta. Now substitute the value. Final angular velocity is 0. Initial angular velocity is 120 pi. Take square of this number, the whole thing square. Be careful when you're taking the square, you have to take the square of the whole thing, 120 and pi, over 2 times 120 pi. And when you solve this, you get your alpha as negative 188.496 radian per second squared, which you can round it off as negative 188.5 radian per second squared. So this is my constant angular acceleration experienced by the centrifuge.